Good afternoon, dear students. I hope everything clear na? This audio, video. Okay, shall I continue? Yesterday we discussed some points about this figure. I hope all of you remember this one. In the same example, in that yesterday's example only, yesterday we already discussed some points about this figure. Let us see some more points about this one. Now for this particular example, in the questions they may ask you to find out what is the power of the each element. What is the power of the each element? Because it is one ideal voltage source. It is also an ideal voltage source. देखिए इधर दोनों का मैग्नीट्यूड सेम है, पोलैरिटी भी आइडेंटिकल है. जब दोनों का मैग्नीट्यूड पोलैरिटी सेम है तो यू कैन से दिस में इनडायरेक्टली अवर केवीएल इज सैटिस्फाइंग. केवीएल स्टेटमेंट क्या है जी? वोल्टेज अक्रॉस द ऑल पैरेलल ब्रांचेस शुड बी इक्वल. इधर वोल्टेज कितने है? इधर 10 वोल्ट्स. 10 वोल्ट्स इज कमिंग अक्रॉस द 2 ओम रेजिस्टेंस. 10/2. देन करंट कितना होता है इधर? 5 एम्पियर्स. करंट इधर 5 एम्पियर्स. देन फॉर दिस एग्जांपल the total current is supplied by the first source as well as the second source. For this example, both sources have the equal magnitude of voltage. Both sources have the equal magnitude of voltage. Then both will supply the equal value of current. Both will supply the equal value of current. Then what the current of this one is? 2.5. Then what about this one? Current of this one also 2.5. Both will contribute the equal value of the current. Then can you find out the power of this one? What is the voltage 10? What is the current equal to 2.5? 25 watts. अब नेचर भी चेक कर सकते हैं आप. देखो इधर करंट गोइंग फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल. हायर टू लोअर बोल तो डिलीवरिंग पावर. डिलीवरिंग. अब रजिस्टर चेक करेंगे. नो रजिस्टर नेचर पता है आपको. रजिस्टर नेचर क्या है जी? हमेशा एब्जॉर्बिंग पावर. रजिस्टर का नेचर कैसे रहते हैं? एब्जॉर्बिंग पावर. नो इधर पावर निकालने के लिए व्हाट इज द फार्मूला फॉर दिस में? आई स्क्वायर आर. देखो जी इन दिस एग्जांपल व्हाट द करंट इज 5 एम्पियर्स. करंट इज 5 एम्पियर्स एंड व्हाट अबाउट रेजिस्टेंस इज 2. अब इधर सिंप्लीफाई करने से व्हाट द पावर इक्वल 50. रेजिस्टेंस नेचर क्या है जी? एब्जॉर्बिंग पावर. 50 वाट्स एब्जॉर्बिंग पावर. सेम थिंग कम टू द लास्ट वन. इधर करंट कैसे जा रहे हैं? हायर पोटेंशियल टू लोअर पोटेंशियल. करंट कैसे जा रहे हैं? हायर पोटेंशियल लोअर पोटेंशियल. अगेन डिलीवरिंग पावर. इधर भी वोल्टेज कितना है? इधर 10. करंट इज 2.5. इट इज ऑल्सो डिलीवरिंग द पावर. हमेशा स्टेटमेंट क्या है जी? कंप्लीट नेटवर्क में टोटल पावर एब्जॉर्बिंग शुड बी इक्वल टू टोटल पावर डिलीवरिंग. टोटल पावर एब्जॉर्बिंग शुड बी इक्वल टू टोटल पावर डिलीवरिंग. Okay, come to the next one. Now still any doubts correspond this third one? I hope all of you remember this one. Yesterday we discussed this equivalent circuits. So far we discussed some examples correspond this third one. Okay, I hope all the doubts are cleared correspond this third one. Okay, now let us take the one more example correspond this fourth one. In this example there goes the resistance connected in parallel to ideal voltage source. There कैसे है resistance connected in parallel to ideal voltage source. Now let us take one example. Now observe here. Now for this particular example, like either resistance connected in parallel to ideal voltage source. Resistance connected in parallel to ideal voltage source. In this example, let us assume load resistance as a now R1 and R2. देखिए how the R1 R2 both are connected series. In this example, the series combination देखिए इधर series combination connected parallel to voltage source. जो series combination है ना, that series combination connected to parallel to this ideal voltage source. The 20 volts is coming across this entire branch. 20 volts coming across this entire branch. Voltage कितना है जी 20. Resistance is 10. Then what is the current of this one equal to 2 amperes. Current is the 2 amperes. Here wherever the current is entering, there is a positive, other one is a negative. कितना है जी voltage 10. Wherever the current is entering, there is positive, other one is a negative. Here voltage कितना है इधर 10. Then with respect to our reduction technique, the 2 ohms can be neglected. With respect to our reduction technique, 2 ohms can be neglected. With respect to reduction technique, that 2 ohm resistance can be neglected. देखिए, if you neglect the 2 ohms, how this R1, R2 both are connected series. कितना जी resistance 10, voltage 20. What the current of this one equal to 2 amperes. Again, voltage of each element is 10 volts. Then for this example, with 2 ohms and without 2 ohms. With the 2 ohms and without 2 ohms. In both cases, load current is same, but the load voltage is also same. For this particular example, with 2 ohms and without 2 ohms, in both cases, load current is the same, load voltage is also same. इधर कैसे बोल सकते हैं जी? The 2 ohms can be neglected. 2 ohms can be neglected to calculate either load current or the load voltage. But in the questions, what they do here? In the same example, they may ask you to find out what the current correspond to voltage source. इधर voltage source का भी current पूछ सकते हैं इधर. They may ask you to find out current correspond to voltage source. देखिए इधर ऐसे बोल सकते हैं ना, voltage across this one, voltage resistance both are same. Voltage कितना है जी 20, but resistance is 2. 20 by 2 means what the current of this one how much? 10 amperes. Current is 10 amperes. If you apply KCL at this point, देखिए 10 outgoing, 2 is also outgoing. Then what is the IS equal to how much here? 12. Getting now? Now for this example, we can write this IS is equal to कितना है जी current? 12 amperes. Can you find out the respective power? देखिए voltage 20, current is at 12. आप ये simplify करने से what the power equal to 240 watts. Power is 240. Come to the second example. In the second example, what we did, the 2 ohm resistance is neglected. If you neglect the 2 ohm resistance, the current of this one, let us name as IS dash. The current let us name as IS dash. इधर ऐसा बोल सकते हैं ना, IS dash and 2 amperes both are the same. IS dash and 2 amperes both are same. इफ यू फाइंड आउट द पावर, देखो जी वोल्टेज कितना है इधर 20 इंटू व्हाट अबाउट पावर इक्वल टू 40 वाट्स. यार ऐसा बोल सकते ना, with 2 ohms without 2 ohms, with 2 ohms without 2 ohms, in both cases that source current is same or different. देखो जी सोर्स करंट सेम or different, different. देखो जी इधर करंट कितना गया 12 amperes, मगर इधर करंट कितना है इधर 2 amperes only. Similarly power also same or different, इधर power भी different. That means here the 2 ohms can be neglected. जो 2 ohms है ना, 2 ohms cannot be neglected, cannot be neglected to calculate either source current or the source power. ये 2 ohms को neglect नहीं कर सकते with respect to what, to find the either source current or source power. Here the it is neglected only with respect to load. किसके लिए neglect कर सकते? It is neglected only with respect to load, only with respect to load. Draw these two figures, write one note. कौन है नो मानवेश जिंदाल. Yes, your messages are coming. Jindal ji, your messages are coming. Yes, your message came exactly at 3 o'clock. 3 o'clock 2 minutes. Okay, write one note. एक नोट लिखो जी. फर्स्ट पॉइंट लिखो. इन द एबो नेटवर्क, इन द एबो नेटवर्क 2 ohm resistance, in the above network 2 ohm resistance can be neglected. In the above network 2 ohm resistance can be neglected to calculate 2 ohm resistance can be neglected to calculate either load current or load voltage, either load current or load voltage, load current or load voltage. Right, the second point. In the above network 2 ohm resistance cannot be neglected. 2 ohm resistance cannot be neglected to calculate either source current or source power, either source current or source power, source current or source power. Okay. Now observe. Yesterday we discussed one more example. देखिए in this fifth one what we concluded, when the current source connected, when the current source connected in parallel to ideal voltage source, when this current source connected in parallel to ideal voltage source, current source can be neglected. This current source can be neglected. Again to understand this one, देखो जी, let us use the same example. The 10 amperes connected in parallel to 20 volt source. When this 10 amperes connected in parallel to this one, load current कितना है इधर 2, but the load voltage is 10. Now in this example, if you neglect the 10 amperes, what is the Is equal to how much here? 2. But include the 10 amperes, what is the Is equal to how much? 12. इधर क्या बोल सकते हैं जी, 10 amperes can be neglected to calculate either load current or the load voltage. 10 amperes को neglect कर सकते हैं to calculate either load current or load voltage. मगर इधर 10 amperes cannot be neglected. जो 10 amperes है ना, This 10 amperes cannot be neglected to calculate either source current, either this source current or the source power. This source current and the source power. That is why from this discussion we can give one common statement as a, whenever you are applying the any equivalent circuit, all these equivalent circuits are valid only to find out response of the load. हमेशा जो रिडक्शन टेक्निक्स अप्लाई कर रहे हैं ना, all these reduction techniques are applied only to find out response of the load. This element cannot be reduced to find out either source current or source power. From this discussion we can give general statement as a, all these equivalent circuits are valid, this third one, fourth one, fifth one. Whenever you are developing equivalent circuits, the purpose of this equivalent circuit is only to find a response of load. Only to find response of load. All these equivalent circuits are valid only to find response of the load. This third one, fourth one, fifth one, all these equivalent circuits are valid only to find out response of the load. Can you write the note with your own statements here? जो equivalent circuits है ना, all the equivalent circuits are valid to find the response of the load. Now next let us go to the current sources. Next let us go to current sources. In the current sources, first let us focus on the ideal current sources. इधर देखो जी, this symbol we can use for the indication of the either for DC source or for the AC source. जिधर symbol दिखा रहे ना, the symbol is utilized for the indication of the either for DC source or for the AC source. Suppose if the time is not given, it indicates the DC source. If the time is not given, it indicates the DC source. Now if the time is given, then it indicates the AC source. If the time is given, it indicates the AC source. But the symbol for this DC and AC both are the same. This ideal current source delivers energy. This ideal current source delivers energy at specified current. This specified current is independent. जो specified current है ना, that specified current is independent on the voltage across the source. What is the meaning of that one? Whatever may be the voltage across the source, always the specified current is a constant. पहले तीनों figures copy कर लो जी. These three figures are correspond which one? Ideal current source. किसके लिए? Ideal current source. Okay, don't worry, I'll reduce the speed, don't worry. Yes, Sheetal, in the above calculation 240 is correct. come to next one. इधर देखो जी. In this example, these three sources, देखो जी, these three are correspond to practical current sources. These three are correspond to practical current sources. इधर देखो जी, practical current source has some internal resistance. Internal resistance in case of the DC. Practical current source has some internal impedance in case of the AC. इधर भी चेक करो एक बार इक्वेशन. देखिए इधर IS current is coming here. Now some current is going to internal resistance. मान लो I dash. If you apply the KCL at this point, if you apply KCL here, IS incoming, what about these two currents are the outgoing? Incoming currents equal to outgoing currents. I dash. For this example, can I select this here? Voltage across this entire branch, voltage of the entire branch both are the same. For this particular example, देखो जी सर, voltage of this entire branch, voltage of the entire branch both are the same. We can write this with I equal to IS minus. Voltage of this one, voltage of this one both are same. We can write this V by RS. इधर देखो जी, if V equal 0, then what we get? I equal to IS. You get the I equal to IS. If V goes on increases, what is the I value is decreases. That means practical current source delivers energy at specified current. That is depends on the voltage across source. The source. Now इधर देखो जी, if the voltage goes on increasing, current value goes on decreases. In this example, if voltage goes on increasing here, current value goes on decreases. मगर इधर देखिए. Now for this ideal current source, इधर देखिए. But for ideal current source, we are not indicating any resistance. बोले तो बोलिए क्या बोल सकते हैं इधर? इंटरनल रेजिस्टेंस कितना है जी? इधर कुछ भी नहीं दिखा रहे बोले तो वी आर इंडिकेटिंग एज ए ओपन सर्क्यूट. इधर कुछ भी नहीं दिखा रहे बोले तो वी आर इंडिकेटिंग एज ए ओपन सर्क्यूट. व्हाट इज ओपन सर्क्यूट रेजिस्टेंस इक्वल टू इन्फिनिट. Thereby in this example देखो जी, every time we get the I equal to IS. फिगर कॉपी कर लो जी. प्रैक्टिकल करंट सोर्स. Yes, Deepa, yes, your statement correct, Deepa. All those are valid only for ideal के लिए, Deepa, yes. Okay. Now write one point. एक पॉइंट लिखो जी इधर. Ideal current source. Write one point. Ideal current source delivers energy. Ideal current source delivers energy at specified current. delivers energy at specified current. In the brackets write I. In the brackets write I, which is independent on voltage across the source, which is independent on voltage across the source, which is independent on voltage across the source. Next point. Next point. Internal resistance of ideal current source, internal resistance of ideal current source equal to infinite. Internal resistance of ideal current source equal to infinite. Of ideal current source equal to infinite. देखो जी सर, आपको याद है yesterday we discussed the internal resistance correspond to voltage source. Ideal voltage source के लिए internal resistance कितना है जी? 0. But for this ideal current source के लिए कितना है इधर? Infinite. And in the questions while solving the problems, we may need the internal resistance of this ammeter and voltmeter also. We may need internal resistance correspond to voltmeter and this ammeter also. About this ammeter and voltmeter internal resistance, clearly again you will read in the measurement subject. आप measurement subject पढ़ते हैं, but just I will give the hints only for this one. हमेशा एक स्टेटमेंट याद रख लो, फॉर आइडियल वोल्टेज सोर्स के लिए इंटरनल रेजिस्टेंस इज 0, मगर आइडियल वोल्टमीटर के लिए इंटरनल रेजिस्टेंस इज इन्फिनिट, एंड आइडियल करंट सोर्स के लिए इन्फिनिट, मगर आइडियल अमीटर के लिए 0. इधर प्रॉब्लम सॉल्व करते समय डोंट गेट द कंफ्यूजन रिगार्डिंग द मीटर रेजिस्टेंस एंड सोर्स रेजिस्टेंस. फिर मीटर्स के बारे में वी विल रीड अ वेरी क्लियरली इन द मेजरमेंट सब्जेक्ट, जस्ट आई एम गिविंग द हिंट्स ओनली हियर. ओके, वो पॉइंट्स भी इधर इंक्लूड करो जी, इंक्लूड दैट पॉइंट आल्सो. इंटरनल रेजिस्टेंस, राइट द नेक्स्ट पॉइंट, इंटरनल रेजिस्टेंस ऑफ आइडियल वोल्टमीटर, internal resistance of ideal voltmeter is equal to infinite, is equal to infinite. Next point, internal resistance of ideal ammeter, internal resistance of ideal ammeter is equal to internal resistance of ideal ammeter is equal to 0. Okay, problem solve करते समय don't get confusion with the meter resistance and the source resistance. Okay, right, the next point और एक पॉइंट लिखो जी इधर, प्रैक्टिकल करंट सोर्स, और एक पॉइंट लिखो जी इधर, प्रैक्टिकल करंट सोर्स practical current source delivers energy, practical current source delivers energy at specified current, delivers energy at specified current. In the brackets write I, in the brackets write I, which depends on voltage across the source, which depends on voltage across the source, voltage across the source, voltage across the source. Come to the next point. इधर देखो जी, again the VA characteristics कल conclude किया ना, बोलिए व्हाट अबाउट दिस VA कैरेक्टरिस्टिक्स, इज इट लीनियर नॉन लीनियर? अरे आपको कल डिस्कस किया था, इज इट लीनियर नॉन लीनियर? non-linear. That means whenever it is satisfying linearity, characteristic should passes through the origin. Can discuss here, that means this VA characteristic is the non-linear. If VA characteristic is non-linear, what about this one? Is it Ohm's law satisfying or not satisfying? Ohm's law is not satisfying. With respect to Ohm's law, always voltage and current should be exactly directly proportional. मगर इधर क्या हो रहा है जी, non-linear. Then we can give statement as a this independent current source. जो independent current source है ना, that independent current source does not obey the Ohm's law. Does not obey the Ohm's law. Reason क्या है बोल तो that VI characteristics are the non-linear. VI characteristics are the non-linear. एक नोट लिखो जी इधर. Write the next point. Next point. Independent current source. एक नोट लिखो जी इधर. Independent current source does not obey the Ohm's law. Independent current source does not obey the Ohm's law. Does not obey the Ohm's law. Since VI characteristic is non-linear. Since VI characteristic is non-linear. VI characteristic is non-linear. Okay, come to the next one. याद है आपको yesterday we discussed some examples for practical voltage source. Practical voltage source के लिए example क्या discuss किया जी कल? One of the example is a battery. और एक example क्या है? Generator. Now can you give reply? Any example for practical current source? Please reply. Please reply. Anvesh saying voice cut हो रहा है. Other students please reply. Any difficulty in the volume? Avanshi saying some difficulty is there in the audio. Other students please reply. Any difficulty in the volume? Example for independent current source. Solar come under the dependent. क्या बोलते solar क्या रहते हैं जी अंदर? It is one type of electronic device. CT current transformer. Current transformer is not source. Current transformer passive element. Current transfer purpose क्या है? It is one type of step down transformer. Inverter source नहीं है जी. Transistor is a dependent source. I want example for independent current source. Transistor किसके लिए जी? Okay. The transistor is a dependent source. Independent source नहीं. चलो चेक करेंगे. Dear students, here remember as in the practical system, independent current source not exist. Only to make the calculation simple. To reduce the network in easy way. To make calculation simple, to reduce the network in easy way, this current source concept is introduced. With respect to this assumption only, source transformation technique is developed. Source transformation meaning क्या है जी? That according to requirement, current source replaced by its equivalent voltage source, or the voltage source replaced by its equivalent current source. In the further class, you will get that one. Why they introduce the current source means only to make the calculation simple. That's why in the practical system, no independent current source exist. मगर डिपेंडेंट करंट सोर्स एग्जिस्ट. क्यों बोले तो कुछ इलेक्ट्रॉनिक डिवाइसेस कैन बी इंडिकेटेड एज वन डिपेंडेंट सोर्स. बेस्ट एग्जांपल क्या है जी? ट्रांजिस्टर. आप ट्रांजिस्टर मॉडल पढ़े होंगे इलेक्ट्रॉनिक्स में. ट्रांजिस्टर कैन बी इंडिकेटेड एज वन डिपेंडेंट सोर्स, डिपेंडेंट करंट सोर्स. एक पॉइंट लिखो जी इधर, एक पॉइंट लिखो. इन द प्रैक्टिकल सिस्टम In the practical system, independent current source does not exist. Independent current source does not exist. But dependent current source is exist. But dependent current source is exist. Dependent current sources exist. Example, transistor. Example, transistor. Example, transistor. Now correspond to current source also. Again, while solving the problems, to make the calculation simple, now with respect to current source also we discuss some equivalent circuits. With respect to current source also we discuss some equivalent circuits. देखो जी इधर two current sources in the parallel. Two current sources in the parallel, both are in the same direction. Same direction बोल तो result क्या है इधर addition. If both are in same direction means result क्या है इधर addition I1 plus I2. देखिए come to second one. Both current sources are in the parallel. Both currents are in the parallel but acting in the opposite direction. Acting opposite direction. Then what is the result of this one? I1 minus I2. मगर condition क्या है इधर I1 greater when compared to I2. On our hand, if I2 is greater, then we write the I2 minus I1. I2 minus I1. Your condition क्या है? I2 greater when compared to I1. First note on these two. Whenever you are applying reduction technique, focus on the current direction carefully. देखो जी इधर I1 greater. जब I1 greater हुआ तो the direction indicated according to I1. If this I2 is a greater, direction indicated according to I2. पहले दोनों फिगर्स कॉपी कर लो जी. इधर देखो जी. In this example, this I1 is one ideal current source. I1 is an ideal current source. This I2 also one ideal current source. When the two ideal current sources are in series, now equivalent value we can add the I1 equal to I2. We can add equivalent value I1 equal to I2 as well as when the resistance connected in series to ideal current source. Resistance can be neglected. Equivalent value is only current source. Similarly here voltage source when the voltage source connected in series to idle current source, when the voltage source connected in series to idle current source, equivalent value is the only current source. Now again, to understand clearly this third one, fourth one, fifth one, in the next step let us take some examples. Now first note on this one, in the next step I will take some examples also. All these equivalent circuits are valid to simplify the calculations. कौन है नो सुमेदे व्यास, इज दिस द फर्स्ट स्लाइड? क्या जी अभी आ गए आप? थोड़ा लेट हो गया जी, क्लास ऑलरेडी स्टार्ट हो गया. Aviral, if any parallel resistance is there, then only it can decrease. If any parallel resistance is there, then the current flow in the load is decreases. Shivam, in the next step, Dubeji, your doubt will be clarified. Next step में clarify होगा. Sanjeev, in the next step I will take examples for dependence के लिए. अब independent के लिए discuss कर रहे हैं अभी. Dependence source we discuss very clearly next step. Okay. Now first let us see some examples for the third one. First let us see some examples for the third one. Read a question. A question लिखो जी. Find current in the 3 ohm resistance. Find current in the 3 ohm resistance. Current in the 3 ohm resistance. Can you select the appropriate option? ऐश्वर्या, all your doubts will be cleared जी. एग्जाम्पल ले तो आप टेंशन मत लो. हाँ, कृषि शर्मा, at the end I will conclude that point. बोलिए आंसर्स बोलिए in this one. What the current in the 3 ohm resistance? Okay. Now let us verify. देखो जी सर, विथ रेस्पेक्ट KCL, KCL मीनिंग क्या है जी? विथ रेस्पेक्ट KCL, करंट फ्लोइंग थ्रू ऑल द सीरीज एलिमेंट शुड बी इक्वल. विथ रेस्पेक्ट KCL, करंट फ्लोइंग थ्रू ऑल द सीरीज एलिमेंट शुड बी इक्वल. इधर करंट कितना है? इधर दिस द 2 amperes. दिस वन एक छोटा करेक्शन कर लो. दिस द 2 amperes, 2 amperes and 6 amperes. Now with respect to KCL, current flowing through all the series elements should be equal. इधर करंट कितना है जी? 2 amperes, other one is 6 amperes. इधर KCL satisfying, not satisfying? Not satisfying. If it is not satisfying KCL, it is not possible to apply our network analysis. क्यों बोल दो? Entire our network analysis is based on only KVL and the KCL. Only based on KVL and the KCL. Then from the options, what are the, in the option they may give the none, or they may give as a not satisfying KCL. In the options they may give as a not satisfying KCL. Direct note लिखो जी. Direct note लिखो इधर. Note लिखो इधर. With respect to KCL, current flowing through, with respect to KCL, current flowing through all the series elements, current flowing through all the series elements, should be equal. All the series elements should be equal. All the series elements should be equal. Come to the one more point. Give the answers for this one. Give the answers. What is the current in the 2 ohm resistance? For this example, what is the current in the 2 ohm resistance? Will you give the reply? Because there, I will explain. For this example, magnitudes are equal. Magar dekho is direction same or opposite? Opposite. Your magnitudes are equal, directions are the opposite. Direction opposite means indirectly we can conclude as a it is also not satisfying KCL. It is also not satisfying KCL. Okay. Magnitude should be equal, direction should be same. Previously somebody asked a doubt about this one. I hope your doubt is clear now. Somebody asked not satisfying KCL. Here be KCL not satisfying. Okay. Very good, dear students. Many students are giving reply. Very good. KCL is not satisfying. Observe here. Previously we discussed one figure when resistance connected. The figure क्या है जी? When resistance connected in series to ideal current source. When resistance connected in series to ideal current source, resistance can be neglected. When resistance connected in series to ideal current source, resistance can be neglected. Again, in this example, let us take one simple example. Load resistance equal to 5 ohms. Load resistance 5. Because there. In this example, what we did? Resistance connected in series to current source. Here देखो जी 6 amperes current is coming. 6 amperes current is coming. Now it distributed in the branch 1, branch 2. Branch 1, branch 2. Can you conclude here what is the current of each branch? 3 amperes. Current of each branch is 3 amperes. Wherever the current is entering, that is positive and other one is a negative. Wherever the current is entering, that is positive, other one negative. Current कितना है जी? 3. Resistance कितना है इधर? 5. 15. Okay. Observe here. देखिए इधर wherever the current is entering, that is positive and other one is a negative. कितना है current? 6. Resistance is 2. Voltage is 12. देखिए इधर correspond arrow mark. Correspond arrow give the positive sign. Other one is a negative sign. Other one is a negative sign. Corresponding arrow mark is plus, other one is a negative sign. VAB. In this example, shall I select this here? Voltage of this entire branch, both are the same. For this example, voltage of the entire branch, both are the same. अब इधर देखिए, with respect to AB terminals, similar polarities are connected together. कैसा है जी, विथ रेस्पेक्ट ए बी टर्मिनल सिमिलर पोलैरिटीज आर कनेक्टेड टुगेदर, सब्ट्रैक्शन। यार कैसे लिख सकते हैं, वी ए बी इज इक्वल टू वी एस माइनस 12। क्यों बोलता हूँ, हमेशा सोर्स वोल्टेज शुड बी ग्रेटर, सोर्स वोल्टेज शुड बी ग्रेटर व्हेन कंपेयर टू द 12 वोल्ट्स। इधर ऐसे बोल सकते हैं ना, वोल्टेज अक्रॉस ए एंड बी, वोल्टेज ऑफ दिस एंटायर बैंड बोथ आर द सेम, what are VAB equal to 15. If you simplify this one, what about VS equal to how much, 27. Come to the power, either voltage 27, voltage 27, but current how much here, 6 amperes, current is the 6 amperes. Now come to our reduction technique. Now according to our previous discussion, देखो जी, according to previous discussion, the 2 ohm resistance can be neglected, the 2 ohm resistance को neglect कर सकते। if you neglect the 2 ohm resistance, now for this example if 2 ohm resistance is neglected, 2 ohm resistance neglected, देखो जी 6 amperes current is coming here, 6 ampere current is coming here, it distributed in the branch 1 and the branch 2, then what is the current of each branch, what is the current of each branch is the 3 amperes, current of each branch is the 3 amperes. Wherever the current is entering, that is positive, other one is the negative. 3 into 5 voltage कितना है जी, 15. That means in this example, with 2 ohms and without 2 ohms, in both cases load current is same, देखिए load voltage also same. इधर क्या हो रहा है जी, with 2 ohms and without 2 ohms दोनों में load current same है, load voltage भी same है, मगर if you see the voltage across the current source, देखिए voltage across current source is the voltage across current source Vs dash, यार ऐसा बोल सकते हैं ना, for this example voltage of this entire element, voltage the entire element both are same, कितना है जी इधर, Vs dash is equal to 15. then if you find out the power formula क्या है जी, now current 6 into 15, 6 and 15. अब चेक करो जी for this example with 2 ohms and without 2 ohms, for this particular example with 2 ohms and without 2 ohms, in both cases voltage across current source same or different, देखिए इधर कितना है जी वोल्टेज 27, मगर इधर कितना है, इधर 15. पावर आल्सो सेम और डिफरेंट, पावर इज आल्सो डिफरेंट. इधर क्या बोल सकते हैं जी, जो 2 ohms है ना, द 2 ohms cannot be neglected to find the voltage across current source or power of the current source, neglect नहीं कर सकते. मगर क्वेश्चन में मान लो इफ ही इज आस्किंग द रेस्पॉन्स करस्पॉन्ड लोड, देखिए लोड करंट कितना है जी 3, इधर भी लोड करंट कितना है, इधर 3, इधर लोड वोल्टेज 15, इधर भी 15. दैट मीन्स सर द 2 ohms कैन बी neglected to calculate either load current or load voltage, मगर सोर्स के लिए नेग्लेक्ट नहीं कर सकते. ओके देखो जी इधर फॉर दिस पर्टिकुलर एग्जांपल फोकस ऑन दिस पोलैरिटीज केयरफुली. हमेशा एक स्टेटमेंट याद रख लो, इधर एरो मार्क के लिए पॉजिटिव साइन, अदर एंड इज अ नेगेटिव साइन. जिधर करंट एंटर हो रहा है, वेयर एवर करंट इज एंटरिंग देयर इज अ प्लस, अदर वन इज अ माइनस. ओके पहले कॉपी कर लो जी. I'll give a note. कौन है मेलू जो, if what happens physically connect the two current source series in the lab. मेलू जो, our statement is the two ideal current source second series. आप लैब में आइडियल करंट सोर्स किधर से लेके आते जी मेलो, लैब में किधर से आते जी, लैब में कौन से सोर्स रहते, प्रैक्टिकल सोर्सेस. अपना जो स्टेटमेंट है आइडियल के लिए जी, आइडियल के लिए नहीं मिलते सिस्टम में, किधर से लेके आते आप लैब में? लैब में कौन से सोर्स रहते हैं? प्रैक्टिकल, नॉट आइडियल. Krushi Sharma, when resistance connected to ideal current source, पैरेलल में नेगलेक्ट नहीं करना है जी, सीरीज में नेगलेक्ट कर सकते हैं. कृषि शर्मा, नेगलेक्ट नहीं करना है. Write the note. Write the note. First point. In the above network, write the first point. In the above network, 2 ohm resistance. In the above network, 2 ohm resistance, 2 ohm resistance can be neglected. 2 ohm resistance can be neglected to calculate. Can be neglected to calculate either load current, to calculate either load current or load voltage. Either load current or load voltage. Load current or load voltage. Next point. In the above network, 2 ohm resistance in the above network, 2 ohm resistance cannot be neglected, cannot be neglected cannot be neglected to find either, cannot be neglected to find either voltage across the current source, either voltage across the current source or power of the current source. Or power of the current source. Or power of the current source. Okay. देखो जी, previously what we concluded, when voltage source connected in series to when a voltage source connected in series to ideal current source. Again here also voltage source does not in the calculation. And one more thing, some of them are asking questions, लैब में ऐसा कनेक्ट किया तो कैसा होता है? लैब में सब कुछ नहीं होता है जी, क्यों बोलते? जो आप डिस्कस कर रहे इधर सब कुछ कौन सा सोर्स है? आइडियल। आइडियल कैसे से लेके आते हैं? लैब में प्रैक्टिकल रहते, आइडियल कुछ भी नहीं रहते। देखिए इस आइडियल सोर्स इज आल्सो रेजिस्टेंस कनेक्टेड इन सीरीज टू आइडियल करंट सोर्स। फिर भी क्या है? वोल्टेज सोर्स कनेक्टेड इन सीरीज टू आइडियल करंट सोर्स। आइडियल सोर्स नहीं रहते जी। समबडी आस्किंग लैब में कनेक्ट किया तो क्या होता है? लैब में प्रैक्टिकल होता है जी, आइडियल नहीं होता है। इधर भी सेम थिंग, वोल्टेज सोर्स कनेक्टेड इन सीरीज टू करंट सोर्स। नाउ फॉर दैट वन आल्सो देखो इधर, if 12 volts connected in series to current source, इधर 12 volts connected in series to current source, कितना है जी? लोड करंट 3, लोड वोल्टेज है 15। if 12 volts is disconnected, कितना है? अगेन लोड करंट 3, लोड वोल्टेज है 15। that means 12 volts can be neglected to calculate either load current or the load voltage। मगर देखिए इधर the 12 volts cannot be neglected to find either voltage across current source। देखिए इधर जब 12 volts है तो कितना है जी? Vs equal to 27। बट इफ यू रिमूव द 12, योर वोल्टेज कितना है इधर? 15। दैट मीन्स 12 volts cannot be neglected, 12 volts this cannot be neglected to find either voltage across current source or the power of the current source। इधर भी जनरल स्टेटमेंट क्या है जी? हमेशा जब इक्विवेलेंट सर्किट डेवलप करते समय उसका पर्पस क्या है बोले तो ओनली टू फाइंड आउट रेस्पॉन्स ऑफ द लोड, ओनली टू फाइंड रेस्पॉन्स ऑफ द लोड। इधर भी देखिए जो इक्विवेलेंट सर्किट डिस्कस किए ना, ऑल दिस इक्विवेलेंट सर्किट्स आर वैलिड ओनली टू फाइंड द रेस्पॉन्स ऑफ द लोड, all these are valid to find response of the load। Okay, write the note with your own statements। Okay, write this question। क्वेश्चन लिखो जी, फाइंड वी नॉट, फाइंड वी नॉट, ड्रा दिस फिगर, फाइंड द वी नॉट, ड्रा दिस फिगर। All of you copied this one, na? इधर देखो जी, in the objective questions every time remember as a if any complex network is given, if any complex network is given, if they ask to find out the response of any element, every time remember as a first you have to reduce the network. If you reduce the network we can easily write the respective mathematical equation. Without reducing network, if you go on solving the problem, it takes the very much time to get the solution. इधर देखिए, ये प्रॉब्लम में with help of the our previous discussions, let us simplify the network. For this example, there is the element connected, this element connected in series to current source. अभी डिस्कस किया ना, when the resistance connected in series to current source, resistance can be neglected. आप इधर कोई भी एलिमेंट ले सकते, आप रेजिस्टेंस, इंडक्टेंस, कैपेसिटेंस कोई भी एलिमेंट ले सकते. In this example here, this inductor can be neglected. Now if you neglect this inductor, इधर देखो जी, for this example, how this 30 and 10 both are in the parallel, 30-10 both are in the parallel and both are in the same direction, opposite direction क्या बोल सकते इधर, 30 minus 10 equal to 20 amperes. Okay, likewise step by step manner, can you simplify the network? Do it, try. Somebody is saying KCL not satisfied. Why the KCL not satisfied? Somebody got 80 volts, somebody got 120 volts. Let's check it out. Don't worry, check करेंगे. अब चेक करेंगे जी. फॉर दिस एग्जाम्पल इधर देखो जी, ये दोनों मिलाए तो करंट कितना है इधर, 30 minus 10 20, दोनों अपोजिट डायरेक्शन है ना. हाँ, इधर भी सेम लॉजिक. when the capacitor connected in series to current source, कैपेसिटर भी हटा सकते हैं आप, हाँ. अब चेक करो जी, हाउ कैन यू डेवलप द सिंप्लीफाइड फिगर. देखिए इधर बोथ आर इन द अपोजिट डायरेक्शन, 30 minus 10 कितना होता है इधर, 20 एम्पियर्स. देखो जी, can I indicate like this? Here what we did, the capacitor also neglected. Can you simplify like this? Now for this example, here देखो जी, this 5 amperes and 20 both are in the parallel. 5, 20 both are in the parallel and both are in the same direction. Same direction बोल तो रिजल्ट कितना होता है इधर 20 plus 5 25 and when the voltage source connected in series to this current source, याद है आपको जस्ट we discussed this voltage source can neglected. I hope all of you getting. अभी आप 5 फिगर्स डिस्कस किए ना, जस्ट ऑब्जर्व द फिगर 5. एक बार फिगर 5 देखो जी एक बार. When the voltage source connected in series to current source, voltage source को हटा सकते हैं आप. Then what are the remaining sources? 25 and the 15. 25 and the 15. 25 and 15. If you simplify further, देखो जी करंट कितना है 25. दिस वोल्टेज सोर्स हटा दिया 25 15. देन व्हाट द टोटल करंट विल बी 40 amperes. Total current is 40 amperes. Now in the series circuit, current of the all elements are the same. Now resistance कितना है जी 2, but the current is a 40. 40 into 2, but the voltage will be how much? 80 volts. Okay. Very good dear students. Okay. Every time remember as a हमेशा ऑब्जेक्टिव क्वेश्चन में एक स्टेटमेंट याद रख लो, कभी भी कॉम्प्लेक्स नेटवर्क दिया तो पहले सोचिए how can you simplify the network. Okay, very good. Somebody got 50. कौन है जी? दत्ता जी 50 कैसा आ गया आपको? कुछ गड़बड़ हो गया, चेक कर लो. शांभवी you got 60. How you got 60? Okay. Very good. Let us see one more example. अब एक क्वेश्चन देखो जी. Write the question. Find V naught. ये फिगर भी लिख लो जी. Arpit Dev, directly we cannot apply. We don't know what is the voltage as current source ना. डायरेक्टली अप्लाई नहीं कर सकते. होना बोल तो निकाल सकते. जो रेजिस्टेंस का वोल्टेज ड्रॉप है ना, दैट इज ओनली कम अक्रॉस द करंट सोर्स. ओके, मेनी स्टूडेंट्स आर गिवन रिप्लाई फॉर दिस वन. अब चेक करेंगे. हाँ देखो जी, फॉर दिस एग्जाम्पल हाउ द 30 and 40 both are connected series. How 30 40 both are in series. कैसा है जी? both are the similar dissimilar polarities. dissimilar बोल तो क्या बोल सकते हैं इधर 30 plus 40 70 volts. Next, when the element connected in parallel to ideal voltage source, either when the element connected parallel to ideal voltage source, element can be neglected. Can you remove this element? Element को हटा सकते हैं आप. Okay, इधर voltage कितना गया जी 70, voltage is 70, minus plus means addition. Can you develop the simplified figure? What is the voltage is 70, देखो इधर minus plus is addition. here पे देखिए. Now for this example देखो जी नेट वोल्टेज कितना है इधर 70, what about other one is 20. now plus similar polarities, the similar polarity बोलते क्या बोलते क्या कर सकते इधर subtraction, similar polarities subtraction. देखिए इधर कैपेसिटर कनेक्टेड इन पैरेलल टू आइडियल वोल्टेज सोर्स. एनी एलिमेंट प्रीवियसली क्या डिस्कस किया था वोल्टेज सोर्स में, व्हेन रेजिस्टेंस कनेक्टेड पैरेलल टू आइडियल वोल्टेज सोर्स रेजिस्टेंस कैन बी नेग्लेक्टेड. यू कैन अप्लाई दैट लॉजिक फॉर द एनी एलिमेंट. आप वो लॉजिक कोई भी एलिमेंट को लगा सकते हैं. व्हेन द कैपेसिटर कनेक्टेड पैरेलल टू आइडियल वोल्टेज सोर्स, दैट कैपेसिटर कैन बी नेग्लेक्टेड. इधर देखो जी प्लस सिमिलर पोलैरिटीज सब्ट्रैक्शन. इन व्हाट नेट वोल्टेज कितना होता है इधर 50, नेट वोल्टेज 50. हाँ अब चेक करो. नो 50, व्हाट अबाउट दिस 10, इफ यू सिंप्लीफाई फर्दर can I indicate like this? Now for this example, corresponds example minus plus, but minus plus means addition, then what is the net voltage is 60, when the current source connected parallel to ideal voltage source, current source can be neglected. What is our requirement is a V naught. How the 4 and 2 both are connected? Series. 4 and 2 both are in series. Kitna is resistance 6, voltage 60. Can you get a current of this one? What a current of this one, how much here? 10 amperes. क्या चाहिए आपको? V naught. Here V naught equal to, we can write this with 10 into 2. कितना है जी voltage? 20 volts. Okay. For this type of the complex networks, try to apply reduction techniques. So somebody got 40, 30. Oh, so many answers. कैसा आ रहे जी 40, 30 कैसा आ रहे? ओ 15 वोल्ट्स. अर्पित देव 15 कैसा आ गया जी? Okay. Next let us come to dependent source. Here the dependent source is indicated by the diamond shaped symbol. In this example, the dependent source is indicated by the diamond shaped symbol. For this example, its magnitude depends on the current. Its magnitude depends on the current. Then what do you write this में current control voltage source. कैसे लिख सकते हैं? Current control voltage source. Here again, its magnitude depends on the voltage. Depends on the voltage. What do you write this में voltage control voltage source. Its magnitude depends on the current. What do you write this में current control current source. Again here its magnitude depends on the voltage. What do you write this में voltage control current source. Now how the dependent source indicated by diamond shaped symbol? It is indicated by the diamond shaped symbol. Again in the questions they may ask what is the unit for this A B C D unit check करेंगे जी. Now for this example, its magnitude depends on the current. Magnitude depends on the current. Then what do you write this means V equal to I into R. V equal to I into R. In this example, what is the A indicated? Which one here? Resistance. In this example, what is the A indicated? The resistance. Then what about unit for this one is the ohms. What about unit for this one is the ohms. B multiply the voltage. Again, what is the result for this one? Again voltage. Again B is no units. इधर भी देखो जी. C multiply the current. Again result is a current. For C also no units. मगर इधर देखिए D multiply the voltage. मगर result what we are getting current. ऐसा लिख सकते हैं ना I equal V by R. Reciprocal of resistance. What is the reciprocal of resistance? Is the conductance. That means in this example, what is the D indicated the conductance. Conductance का unit क्या है इधर? Okay. Generally in the practical system, what they do here, while doing the mathematical analysis, that electronics devices are indicated as the dependent sources. That's why remember as if any dependent source is given, its meaning is in that particular network one electronic device is present in the network. Generally that electronic devices are indicated as a dependent sources. एनीवेयर अतुल राय किधर भी लगा सकते हैं जी. मगर वो कंडीशन है ना, कंडीशन सेटिस्फाई करना है जी अतुल राय. Okay. Now can you give reply? Please give reply. Out of these four sources, which are the linear and which are the non-linear? बोलिए जी, give the reply. Out of these four sources, which are the linear and which are the non-linear? Please give reply. कौन है नो Abhidas. These are the dependent sources. See, previously I discussed about the independent sources. Okay. To understand easy way, just observe this example. To understand easy way, observe this example. Suppose in the question, if it is given like this. In the question, if it is given like this. Can you please conclude? Is it linear or non-linear? For this particular example, the current source magnitude directly proportional to I square. For this example, this current source magnitude directly proportional to I square. आप इधर current source को I को graph develop करें तो what the shape of the graph will be? Linear, non-linear. In this example, current source directly proportional to I square. Relation कैसा आ जाएगी? Non-linear relation we are getting. That's why it is one of the best example. Now it is we name this one as a non-linear dependent source. Getting now? We are getting non-linear relation. क्यों बोलते? Source current directly proportional to I square. Source current directly proportional to I square. मगर इधर देखिए. In this particular example, source magnitude directly proportional to current. Either suppose current increase by 10%, voltage also increase by exactly 10%. If current increase by 90%, voltage also increase by exactly 90%. It will be same thing. That means if you draw the graph between the voltage and current, shape कैसा आता है जी? Linear. Either be same logic. If voltage increase by 50%, source voltage also increase by exactly 50%. If voltage increase by 90%, source voltage also increase by exactly 90%. इधर भी कौन सा shape आता है जी? Linear shape. That's why here remember as a all the four sources. In this example, all these four sources are the linear dependent sources. Linear dependent sources. Linear dependent sources. Okay. Okay, very good. Okay. Dear students, I hope all of you remember yesterday I gave the reference books. In that one, what is the first book is that Alexander Sadiku. Okay, now this is a link correspond that one. It is the link correspond this one. All these are the capital letters. If you open this link, there are two files are there. One is the textbook correspond this one. And one more file is there. The solutions for the exercise problems. Exercise problem solutions. Okay, all of you try to download this one, maintain this one as a reference. एक बार try करो जी आप, तुरंत download कर सकते हैं आप. Yes, Bhavana, your statement correct. एक बार ट्राई करो जी, लिंक ट्राई करो. dear students, all of you try to download this one, maintain this one as a reference. Good number of questions are available in this one. Okay. Somebody asking about the Medici theory book. Dear students, said remember as a in that Medici theory book you might have seen they include the both objective questions and conventional questions. Right now don't focus on the conventional questions, concentrate only on the objective questions. You might have noticed in the theory book assignment 1, assignment 2 is there. Now right now focus only on that objective questions. Okay. This is other reference. Our Medici theory book is one reference. In addition that one I am providing one more reference for this. One more reference. Here कुछ भी other sources जाने का जरूरत नहीं है जी. अपना class notes, our Medici theory book and Sadiku book, our previous papers and workbook, these are the more than enough. और कुछ भी जाने की जरूरत नहीं है. Unnecessarily don't waste your time. The sources which we are providing, these are the more than enough with respect to exam point of view. Okay. Anu Kumari workbook I will provide after completion of the first unit. Okay ji. Divyananda Sri support kar rahe ji. And one more thing dear students, if anybody getting problem in the downloading, मुझे telegram में request भेजो, I will send the PDF to you. Okay. Okay dear students, today I am closing the class. And one more thing, okay, if PDF is support download नहीं हो रहा तो dear students, if it is not downloading in your mobile, later send me to Telegram. मेरा Telegram में भिजवाओ जी. Okay. And one more thing dear students, tomorrow there is no networks class. Tomorrow networks class नहीं है. Okay. Day after tomorrow timings are the same. Day after tomorrow timings are the same. 2 to 5 or 5:30 day after tomorrow. जिप फाइल ओपन होता जी, दैट इज अ रैर फाइल. मोबाइल में सॉफ्टवेयर डाउनलोड कर लो. यू आर द न्यू जनरेशन स्टूडेंट्स. छोटा फाइल ओपन नहीं कर रहे आप, ऐसा ये तो कैसे? ओके.